Welcome to 13.3 Trigonometric Functions. We're going to find values of trig functions today. First, there are 6 trigonometric functions that you need to know. Sine of theta equals opposite over hypotenuse, cosine of theta equals adjacent over hypotenuse, and tangent of theta equals opposite over adjacent. You knew these already because we did this in 13.1 as well as in geometry. So the 3 new ones are cosecant, secant, and cotangent. Cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. You should notice these are the reciprocals of the original 3. That's because cosecant is really just 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. So find the 6 trigonometric function ratios for angle A. So we're going to use sine, cosine, tangent first because that's the ones we already know. According to angle A, the opposite is 4, the hypotenuse is 5, so sine is 4 over 5. The adjacent is 3, the hypotenuse is 5, so 3/5 for cosine, and tangent is 4 over 3, opposite over adjacent. Cosecant becomes 5 over 4, secant becomes 5 over 3, and cotangent becomes 3 over 4. Alright. We can find exact values of trigonometric functions of theta on a coordinate plane. So theta is an angle in standard position with the coordinate point xy, and that's the point on a terminal side of theta. Using Pythagorean theorem, all we have to do is find r equals the square root of x squared plus y squared. So if we have a right triangle, as shown above, theta is our angle, r is the length of our hypotenuse, x is the length we went to the left or right, y is the length we went up or down. So sine theta would be y over r. Cosine theta would be x over r. Tan would be y over x. And cosecant, secant, and cotangent are the reciprocals. So we're going to find the exact values. We have the coordinate point 5, -12, so we're going to graph that. We draw a right triangle. We went 5 to the right, down 12. We're going to square both those numbers and add them together and take the square root to get the radius, which is 13. So now we can do sine. Sine is -12 over 13. Cosine is 5 over 13. And tangent's -12 over 5. Do the reciprocals. Cosecant is 13 over -12. Cosine is 13 over 5. Tangent is 5 over -12. Alright. To find the values here, given the standard position that measures 270, first we graph that 270, and that goes from the standard position, we go all the way around to the y-axis on the bottom. We can't really draw a right triangle here because it's straight down. And so our coordinate point is at 0, -1, and our radius is the length of 1 because it went down 1. So to find sine, cosine, tangent here, our sine is 0 over 1. So it's 0. Sorry, it's -1 over 1. Our cosine is 0 over 1, which is 0. And our tangent would therefore be -1 over 0, which is undefined. So our cosecant is 1 over -1, so it's -1 still. Our secant is 1 over 0, which is undefined. And our tangent would be 0 over -1, which is 0. We can also use special rights to find exact values for trigonometric ratios. So you got the 45, 45, 90, which is the side lengths of 1 and hypotenuse of square root of 2. On 30, 60, 90, we got the short leg is 1, the hypotenuse is 2, and the long leg is radical 3. So the sine of 30 would be 1 over 2. The cosine would be square root of 3 over 2, and the tangent would be 1 over the square root of 3. But we always rationalize it, so we multiply by the square root of 3 over 3, square root of 3, and we get square root of 3 over 3 as our answer. So that's why we have that there instead of 1 over radical 3. Cosecant would be 2 over 1. Secant would be 2 over radical 3, which we rationalized to become 2 radical 3 over 3. And cotangent would be radical 3 over 1. The 45, our sine and our cosine are the same. It was 1 over the square root of 2, which becomes square root of 2 over 2 after we rationalize. Tangent's 1 over 1. Cosecant and secant is square root of 2 over 1. And cotangent's 1 over 1. 60 degrees, the same as 30 degrees, except we switched the location of sine and cosine, cosecant and secant, as well as tangent and cotangent. Alright, we can use that information in order to find our values, as long as we have their reference angle. Reference angle is just the angle formed by the terminal side of theta and the x-axis. So 135 degrees. We can draw that angle, and then we create a right triangle using the terminal side. So this angle is just 180 minus 135, so it is 45 degrees. Now 240 goes past the 180 degree mark, but we still create that terminal side with the x-axis. This time it's part of the circle, so we're going to subtract 180 from 240 to find this angle. And that's 60 degrees. Negative 30 goes down 30 degrees, part of the right triangle. So this is just 30 degrees. Negative 480 goes past the full circle, and then it goes 120 more. 120 more, we subtract that from 180, we get 60 degrees. So we're going to draw a picture and give the exact value of each trigonometric function. First, we need to find the reference angle. So we have 120 degrees, 180 minus that, 60 degrees. That's our reference angle. We draw this right triangle. We went negative 1 to the left, up radical 3, and then our hypotenuse is 2. So it wants the sine, that's opposite square root of 3 over hypotenuse 2. Square root of 3 over 2 is our answer. Cotangent of 3 pi over 2. Now 3 pi over 2 is not a degree, so let's first change it to degree. We're going to multiply by 180 over pi. We get 270 degrees. Now that goes past the circle. So we subtract 180, so we get 90 degrees. And that creates this line straight down. We can't create a right triangle. But our coordinate point is 0, negative 1. And our radius is 1. Cotangent would be 0 over negative 1, so it's 0. Last two, tan of 135. That is 45 degrees past, so our reference angle is 45 degrees. So we draw this, negative 1 to the left, up 1, radical 2 with the hypotenuse. It wants the tangent. So opposite is 1, adjacent is negative 1, so our tangent is negative 1. Alright, for the next one, cosine negative 7 pi over 3. Negative 7 pi over 3, we're going to change to degree mode, so we're going to multiply by 180 over pi. We get negative 420. Now that goes beyond the circle, 60 degrees, so we have 60 as our reference angle. It's going to go to the right 1, down radical 3, so that's a negative radical 3, and hypotenuse is 2. So here cosine is adjacent, which is 1, hypotenuse, which is 2, so it's 1 over 2. Alright, that is it for trig functions. Good luck on the practice. Yep.